Hello everybody, and welcome to Tuesday Theory Talks. This is a weekly snippet of sailing trivia. It's going to take you from how a boat works to a better understanding of how a sailboat works. I'm going to be your coach for this weekly update. My name's Lieutenant Zachary Sellers. Today we're going to start with talking about airfoils, airflow, Bernoulli's Principle, and pressure, in that order. Let's get going. Alright, let's imagine a sail from above. Any sail will do, but we can talk about a mainsail on a 420. So here's the mast, looking down on it from above, and there's the mainsail. So our sails move our boat, and they do so by having airflow around them, passing on both sides of the sail. Air comes down and goes around both sides of the sail, just like that. We call this flowing air by a pretty obvious name. We call this airflow. Any curved object that has a fluid flowing around it, we call a foil. When it's in the air, we call it an airfoil, like an airplane wing or a sail. When it's in the water, we call it a hydrofoil, like our centerboard or our rudder. But the basic word foil just means a curved object that has stuff flowing around it, and that's just like our mainsail here. Now, all the foils on a boat are very carefully designed. They're curved and shaped in very particular ways, and also, as a result, we can use Bernoulli's Principle to get a basic understanding of how they work. Bernoulli's Principle, first explained by a fellow named Daniel Bernoulli in 1738, says that there's a connection between the velocity, or speed, of a fluid and the pressure of a fluid. Specifically, if everything else is the same, a fluid that is going faster will have less pressure. If a fluid is going slower, it has more pressure. So let's look at our foil, our mainsail. It is curved in such a way that when wind passes around both sides of the mast, the airflow along the leeward side moves faster than the air on the windward side. Leeward moves faster, windward moves slower. Now, what did Bernoulli say? He said high velocity, low pressure. So high velocity, the side that's going faster, has low pressure. And the side that goes slower, the windward side, has high pressure. Windward side, slower air, higher pressure. Leeward side, faster air, lower pressure. Get it? Got it? Good. At this point, when I was on intermediate sail in 2006, were you all even alive back then? The first question that came up for me was, why does the wind go faster on one side of the sail than the other? I can't explain it to you simply. That's why you need to go to university and study fluid dynamics, and then come back and teach me. But it does go faster, and we know that because we can feel the change in pressure. And so Bernoulli's Principle tells us the velocity changed. So what is pressure, by the way? Well, let's imagine blowing up a balloon. The pressure inside the balloon is higher than the air outside the balloon. That's why the balloon expanded and is now firm. The air inside wants to get outside. High pressure air always wants to go towards low pressure air. If I let go, the air rushes out of the high pressure balloon and into the low pressure air of the ring. So on our sail, we have a windward side, which has slower air with high pressure, and we have a leeward side with faster air and low pressure. So where does the air want to go? It wants to go from the windward, right here, to the leeward. That's the way it wants to move. It wants to move in this direction, from the windward to the leeward. It tries to push in that direction, but the sail gets in the way. Our sail right here blocks it, and that's where we get pressure on our sails. The force in our sails then helps us move our boat, but how that works, we'll talk about next week. Alright, that's it for this week. If you have any questions, please throw them in the comments below, and I will do my best to answer them, and then we'll cover some more theory next week. See you then.